Hello, my dear friends. Today, our main aim of our project is stock movement prediction using the Twitter sentiment analysis. Sentiment analysis means the emotions of each person between the Twitter tweets on basis. For that, we are using the Twitter. The main platform which was that can be used for the everyone like professionals and other members like tweets. They are sharing their tweets depending on their moods and the different senses. For that, depending on that, we are predicting the stock market based on that. For that, we have to use the live data. For that, we are using the tweet. Dot tweet. First, we have to install this library. After that, for using this library, we have the API of the Twitter. For that, we are using the Twitter of the authentication of the data, the Twitter API authentication. Next, we are using with the client that can be seen. Then the data was saved into the tweets.csv. The maximum we are using the data is 100. Then the data was every time we are using the same data. For that we have the recurrent data we have to use. For that we are taking the time slot stream. It was take the data after for every 15 minutes it was taking the data. Totally we are using the 99 we are taking the 99 tweets from the whole present perception data on that basis. Then we are pre-processing the data. For that pre-processing, we are using the various techniques like the first read the data and the duplicate values removing and the null values removing, dropping the unnecessary values and cleaning the links and other techniques. And we are using the low converting the uppercase to lowercase methods. These are the different types of cleaning techniques which we are using in this. Then we are filtering the non-English text tweets and other languages. For that we are cleaning the data and the process data was saved into the clean underscore tweets.csv. Then we are going to the sentiment analysis on tweets. For the further analysis, we are taking with the sentiment. On that features, we are extracting with the positive sentiment analysis, negative sentiment analysis, and neutral sentiment analysis. For that, we are analyzing how many are there for the positive and negative and neutral. We are constructing with the graph, like we are using the bar chart. We are mainly using it. In this, we can easily understand how many are positive, how many are neutral, how many are negative tweets from the given data. There are mostly more than the positive tweets are more than 55 to 60. The neutral tweets are more than the 22. The negative tweets are so much less. On the time we are extracting the data, there are negative tweets are so much less. On that basis, it was steady. Next, we are using the processing, pre-processing the data, text count vectorization. These are different types of techniques which we have in this. Then we are mentioning the stock market prediction analysis. There are different types of stocks. For that, we are using the Tesla, Apple, and stock and market. These are the different types of specific stocks we are using. On that basis, when we are extracting the data, the Tesla mentions is 0 and Apple mentions also 0. For that, we will see the tweets in the stock market. On that basis, we are mostly getting the stock mentions and market mentions. They are mostly high. That's why we are visualizing this. There is no data with respect to Tesla and Apple. That's why it is representing as it. Okay. Then we are combining with the word cloud. The word cloud generation is mainly used to how the data was representing, how many times. The most recurrent data was representing the highlighted text. For that, we are using the word cloud. The most frequent values are presenting as the bigger size and preparing the data for stock movement prediction. For that, we are splitting the data. The most of the data which we are using for the training. For training, why we are using the most of the data. When we are using the most of the data for training, the better prediction we will get. For that, the best test size and train size is 7:3 and 8:2. This is the best testing and training size. For that, in our case, we are using the 8:2. In that ratio, we are getting the best accuracy. For that, for the purpose, we are using the text vectorization and feature combination shorts in the explanation. For that, we are initializing it to the text maximum features and the feature extraction was done. Then we are going to the logistic, combining with the logistic regression with the random forest by using hypertuning. In this, we are which search series we are using for the hypertuning mechanism. This is the code which we have for using the logistic regression hypertuning. For that, we are best accurate model we are getting as C equals to 10 and solver equals to linear. For the best accurate line we are getting for the random forest is maximum depth is none. There is no depth we want to take in this. And next purpose we are using minimum sample width is 1. In this position we are getting the most accurate model. For that it was taking this. Hypertuning is mainly used for the best fit line, for the better accuracy which we have to do. Okay, in further analysis. For that we are using this. Then we are going to the ensembling learning with the voting classifier. We are combining the both hypertuning mechanisms into the single model by using the voting classifier. In this, we are using the voting classifier as hard. Why we are using hard, not soft? When we are using the soft mechanism, we are getting the mostly the overfitting mechanism. On that basis, we are going to using the soft in this case. In this case, we are using the hard. In this, we can get the best accurate model in this. When we are extracting the data, what we are getting the model classification analysis. The most accuracies we are getting is 94% of accuracy we are getting by using the voting classifier performance. Then the classification report is given the precision, recall, and upfront. Then we are going to the cross validation voting classifier. Then we are combining the voting classifier with the CV. We are using the M splits equal to 4. The best fit line we are getting in this. Further mechanism, we are using the best accurate model and the better matches we are getting. In this, we are getting the most accurate model as 94% of accuracy, which we are getting from the same as above. As soon as the precision recall is performance score is increases. On that purpose, we are using this the cross validation function. Then we are comparing the machine learning models with the deep learning model. In this, we are using the activation functions as and dropping functions, ease and overfitting layers are sigmoid function we are using. The shocks up and downs was predicted by the DNN model. Then we are combining with the DNN model, we are using the torch. For combination with the better accurate model, we are predicting that can be using by the hypertuning. In this combination, we are getting. The combination is the K-fold hypertuning was we are doing this. These are the different types of layers which we are taking for the DNN model, and these are the different types of parameters for hypertuning we are using. Further accuracy model was the best fit line we are getting is the average accuracy we are getting is 93% of accuracy we are getting the most accurate part. For the best accuracy we are getting 1. It is war fitting the data. On that basis, we are predicting with this. The average accuracy model, what is the how the data was predicting? By using the true positive rate and false positive rate, we are predicting them. We are getting the ROC curve as 1. The true rate is mostly high. The false rate is so less. On that basis, the ROC curve is mostly high. But the best fit line is high. Next, we are doing the sharp method. Sharp is the model interpretability, model interpretability. It is mainly used for how the model is predicting, how the model accuracy the model was reading. On that basis, it was building this shop. On on which features it was building as best. On that basis, it was building the features. Eight on the basis. Next, we are going with what we are discussing between the machine learning models and deep learning model. How the accuracy was defined. In the machine learning model, we are getting the 94% of accuracy. On the deep learning model, which you are basing, has 93% of average accuracy we are getting. On that purpose, we are using this differentiating with the part. In this, the machine learning model is most accurate to predict, and the deep learning model is more particular. In further purpose, it was able to do or not, we cannot really able to confirm. On that basis, the machine learning model is best. It can furtherly proceed and upscaling the further processes. Thank you.